Welcome back to my channel Kishore Sir Ki Pathshala. We are doing chapter carbon and its compounds. That's for 10 Cbse. So last time we have seen what is structural isomers. We have seen what are the ring carbon compounds. Right. So today we are going to see allotropes of carbon. What is allotrope of carbon? Allotropy is nothing but it is a property by which the element can exist in more than one form that is physically different and chemically similar as such, right? So we know that carbon exists in different allotropic form. Okay, that is my diamond, graphite, and fullerene. Okay, so diamond and graphite we have been studying from standard 6 itself. Okay, so two different structures, that is diamond and graphite, having a very different physical properties even though their chemical properties are the same. So this is what we are going to see. So let's see some differentiating points between the diamond and graphite. Okay. So in diamond what we see is that each carbon atom is bonded to four other carbon atoms forming a rigid three-dimensional structure. Right. Here you see the carbons are arranged like this in a way. Okay. So here will be carbon again. Right. So like this they are arranged. So every carbon here linked like this. So it will be like this. Okay. Four other, see here, carbons they are linked. Okay. So what is happening? The tetravalency is meeting. That we need to understand. All right. Okay, now in case of graphite, what you see is that each carbon atom is bonded to three other carbon atoms. Here, each is bonded to three other carbon atoms like this. Here you see, right? Okay, then what you have? Then you have a double bond. Okay, one of these bond is a double bond. Okay, so one of these bond is a double bond as such in this case, right? And thus the valency of the carbon is satisfied, right? Okay, being a double bond in one of the case, so valency is satisfied. Then the diamond is what? It is the hardest substance known. Okay, diamond is the hardest substance known on the earth, right? So graphite, you will see that graphite is nothing but it is a soft form of carbon. Okay, so graphite structure is formed by hexagonal arrays placed in layers, right? Placed in layers one above the other. Okay, graphite is how it is smooth and slippery, right? Graphite is also a very good conductor of electricity, right? So you'll see that the graphite rods are being used in electrolysis purpose as it conducts electricity. Diamond is not at all a good conductor of electricity. So these are the few of the differentiating points between diamond and graphite as such. Now you see the third allotrope of carbon is what is my fullerene, right? So these fullerene is, uh, is another form of carbon allotrope. Okay, the first one to be identified as what? As C60, right? C60 carbon 60. Okay, which has the carbon atoms arranged in a shape of a football. Here you see carbon atoms are arranged in a shape of a football. It is like this. Okay, arranged like a football. Now, since it looks like a geodesic dome, a US architect, Buckminster Fuller, okay, named this, the molecule was named as fullerene. Okay, so the molecule was named as fullerene. So I'm sure you have understood today's topic, that is the allotrope of carbon as such. Alright, so we have seen that allotrope, allotropy is nothing but it's a property by which an element can exist in more than one form that is physically different and chemically similar as such. Alright, so we have seen the differentiation between diamond and graphite. Okay, how to differentiate between them, how there is a structural differentiation between these two, between the diamond and graphite, how they are arranged, and the uses also differ according to their properties. Okay, student, I'm sure you have understood today's topic. So kindly like, share and subscribe my channel Kishore Sir Ki Pathshala for more informative videos.